Good morning, and welcome to the CCIF Education Series webinars. I'm your host, Patrice Marcil, and I'm very pleased that you are all here today at this very first education series that we actually announced in Toronto in January, and then we all know what happened, and we finally get to come to get those webinars up and running, and we're very happy that you are here today. So here's the just a few things that I want to go over. First of all, I mean, those events, as I was saying, that's part of the education series. We're looking at a 60-minute event here today, and we are going to run those webinars in March, July, and in November, which is right in between the CCIF events. We have a tech session in the morning at 11, like this one, and then in the afternoon we have a management session at 1 p.m. all Eastern time. And the topics that we select are usually follow-ups from the CCIF meetings, and they can be around equipment, products, services, around manufacturers, or around any kind of procedures. So if you have any suggestions, or if you would like to participate in those webinars, just reach out to caroline.lacasse@ccif.ca, and you can make any suggestions. We'll be more than happy to have you on board on this. A little bit of housekeeping before we start. Microphones are muted, just to make sure that we have we stay away from any sound obstructions here. There's Q&A. If you want to ask questions, just look at the bottom of your screen. There's a toolbar there. You can click on Q&A, and you can ask a question to the presenter or myself at any time during this webinar. You can chat with participants too. So if you click on the chat function, you can chat with selected people or with everyone, and you're more than happy to do that. There is going to be a poll during a couple polls probably during the session. So it's important that you participate and you provide us the feedback, because this is part of the process here. Again, the session is recorded, and it is going to be available on demand at ccif.ca soon after the session. Moving on to absolutely, February 3 and 4, we're going to have our virtual CCIF, our second one. So you are more than welcome to attend. You just need to register. There's an early bird registration right now till the end of December. So hurry if you want to take advantage of the rebate here, but everybody needs to register. So you will find all the information at ccif.ca. And also, before we go any further, I mean, this would not be possible if we wouldn't have the support of all of our sponsors here. So let me just take a minute here and acknowledge them. So it is very important that, I mean, this would not happen at all. And even though those tough times that we've been going through, those sponsors have all been very good and very supportive. And that's been like that for many, many, many years. And it is very important that we recognize that. So thank you very much to all of those precious sponsors. We really appreciate your help here. And the only reason why we are capable of doing those kind of events, webinars, all this, that's because of the support of everybody here. So well, thank you again. And today's session is making panel repairs faster and easier. So what I would like to do now is just to quickly introduce Dave Flockhart from BETAG. Dave Flockhart is BETAG Innovation Chief Operating Officer. He has a detailed understanding of the North American collision repair industry, and for the past 8 years has been responsible for BETAG's drive to deliver effective technical training and advanced equipment in the US and Canada. As BETAG continues to focus on improving the knowledge, skills, and performance of collision repair estimators and technicians around the world, Dave is also leading the rollout of BETAG's new learning center to OEMs and body shop group. Without any further ado, I'd like to introduce Dave Flockhart. Dave, This show is yours now.
Thanks, Patrice. Thank you very much indeed for giving us the opportunity to present this webinar today. Good morning, everybody. We're going to spend the next 45 minutes or so, as Patrice said, speaking about or sharing some of our insights into how to make panel repairs easier and faster, critically without any compromise to the quality. This course that we're doing, very technically focused, it forms part of what we call our medium panel repair class and our medium panel e-learning program. So it's supported by some e-modules, and we're going to open up access to those e-modules after the webinar today. The guys at CCIF will share the information so that you can access those once the webinar is over. And the other thing that we've done, and the link is in the chat, it's actually up there at the top of the chat, if you can see that. That's a link to the workbook. So for all of our classes, whether they're instructor-led on-location classes or whether they're e-classes, we produce workbooks. If you click on that link, I think it will download the workbook which accompanies the webinar today. It's a PDF document, you can type directly into that if there are any notes that you want to make. And we'll also jump in and out of it as we go through the next 45 minutes together. So without further ado, I'm going to hand over to my colleague, Ralph Maestri, and we're going to dive straight into the technical content of today's webinar. I think you might be on mute, Ralph.
Okay, can you hear me, everybody?
There we go.
Okay, I apologize about that. My name is Ralph. Thanks, Dave. Thanks for the opportunity to present this to you. The next 45 minutes going to be a little bit of action-packed. We're going to cover two subject matters. One is damage analysis. First, about how to look at damage, how to identify the different zones in the damage, marking up the damage so we know what we have to repair. And then after that, we'll be doing two repairs, a 90-degree edge repair and a trunk lid repair here, an edge to straighten that. So yeah, let's take it over to like Dave said, you have also a PDF which you can download from the chat. If you can open up and keep it open on the side, if you want to take notes on that, just to give you a little bit more of a reminder of the content that we have covered or will be covering. So damage analysis, identify the different types of damage, identify the different shapes of damage, marking up the damage, and explain the extent of the damage to the customer and to the insurance. That's the first part. So let's start with something simple. Soft dents, elastic deformation, sharper dents, plastic deformation. What is that? Elastic deformation, it's something is when you bend a piece of metal or aluminum or paper or plastic. If it returns back to its original shape, the molecular structure has not been changed in the material. It's called elastic deformation. Small light damages, waves in the panel, or traditionally elastic deformations. Plastic deformation is something when you bend past the yield point, meaning the material is stretched and elongated, and it will not return anymore. Okay. So here you see also at the bottom right corner of the PowerPoint there, WB3 stands for workbook page 3 for the people who want to take notes and follow up while I speak. You can see it here, also page number 3 to take notes if you don't type it in there. So this again is this plastic deformed sheet metal. Average thickness is 0.7 millimeter thick. The outer part of the metal is stretched. The inner part is neutral, and the center part is the crushed area where molecules have been changed. So let me just quickly show you that on a live example. We have here 3 different materials. This is paper. 1 second. Okay. So if I bend it and apply my pressure, if I go past the yield point, so if it returns, this is elastically deformed. If I go past this point, now it's stretched, this is plastically deformed, okay? And that's important to identify because in the repair process, this will be the more difficult point to repair in the process. The same thing here, we have it on the plastic. It's a little bit easier to deform, but also plastic, you have your point of no return where you have your plastic deformation in the center. And now here we have the difference between aluminum and steel. On one side, people say that aluminum, this is steel, so you can bend it, and then quite soon you get a plastic deformation point, a stretched area in the middle. Aluminum, harder or softer. Some people say it's harder, some people say it's softer. Actually, on the full surface, it's softer. That's why you have on the panels more reinforcement on the backside. But on actual point, impact point, the aluminum is stiffer. And that's why you have a lot of creases or cracks on aluminum panels. But also here, you can bend it. And once you go past that point, that's the yield point. That's a plastic deformation. Okay, so if you look at the graph, this here represents what we've been looking at now. So the yellow, the green curve on the bottom is plastic. So the yield point is quite low, 30 megapascal, but it stretches quite far. That's why you have the long percentage of elongation. And then the difference between the red and the blue line, red is aluminum. So the yield point where it starts to change the form from elastic to plastic is quite low. And this is considering to be an outside panel. And then the tensile point where it breaks is lower than the steel. That's why it cracks more. The blue on the other side, on the normal outside skin on the vehicle, plus minus 230 megapascal. At that point, it changes shape from plastic deformation. And then you apply more pressure until the cracking occurs, but it definitely stretches more at the same time. Okay. Here you see piece of panel. Green is the panel. We apply pressure. Low energy being induced. It keeps stretching a little bit. Now at some point it changes from elastic to plastic. So the impact point is now getting stretched and elongated. The more you apply, the center gets larger, the plastic deformation, the material starts to stretch. But important to note, on the outside, you still have the elastic deformation. Okay, so here you have both. And the center is the stretch part, and the outside is the elastic. Okay, and so, as soon as you apply more pressure, the tensile point gets over pushed, and then the material cracks. Okay, so here's an example in a small damage. Inside impact areas, plastic deformation, outside elastic. Okay, and why is it important to identify these different zones? Definitely on one side, it depends what kind of repair process you will choose. It will depend how long the time will take. And then on the other point also, if you have the skill to repair. So naturally, the more deeper or stretched material is, the more challenging or the more fun it gets to repair these damages. Okay. So here we have a damage also for the people who have the PDF. Okay. So here we have the different types of zones in it. The red area there, you can write it in, or I don't know if you see the chat function on this. If not, the red area, top left is the original shape. On the right side, you see how it's marked up. So the red area is the impact area, the body line, also the area where the material is stretched. That's important also in the repair process when before you weld on the bits, that you really clean off the E-coating there properly, that you have got contact on the in the welding process. Then the outside is the elastic deformation, and then always now the third area is the crown where the metal has gone out of the original shape. Okay, I'll speak about this later on a little bit more in detail. Okay, 1 second. So here we have an example. Okay, if you want to take notes on workbook page number 7 for the ones who've been able to open it, or even on the chat, you can take comments or type your opinion. The tip of the arrow is pointing to an elastic point or a plastic deformation. I don't know if anybody wants to type along and give your chat comment on that. So the actual point of the arrow is pointing at an elastic deformation. Next part here. Point of the arrow, what do you think? Look at it. Elastic or plastic? Yes. So this red panel, elastic, was correct before. Thank you for commenting or giving your comments on the chat. So in this example, the pointy on the blue arrow, the point of the arrow is pointing at a plastic deformation. You see the deformation higher up on the panel, but all of that elastic. So it's actually a large area which is to be repaired, but because just the lower part is plastically deformed, the upper area is elastically deformed. That makes it actually an easy panel to repair. Okay. Here is how it happens. Impact point, slow motion. So the impact area where the object which hit the outer skin made contact, most of the time plastically deformed, stretched, elongated. And then the second part is the elastic section on the outside, which is deformed from the energy from the impact. And then naturally you have the crowns, which is not shown here on the next panel. So here you have an example of that. Again, on page number 8, you can take notes on that if you want. So line A represents the original panel. Oh my God, my writing is horrible. Hold on, my keyboard is wrong. That's why I change it now. I give up the writing, guys. I'm sorry. The red represents the direct impact area, plastic deformed. The secondary impact is then the crown, the elastic area, and then the green part is the crown, where the metal has been pushed out. Okay. This is a flat surface, a crease in the middle of the door. It looks a little bit similar. We have the impact area, which is marked by red, elastic, which is marked by yellow, the crown, which is a little bit smaller due to the fact that it's a flat panel. But now we have a fourth area. We call it associated deflection zone, which happens often on flat panels. When the damage occurs, the whole panel gets pushed in further in than what you see. And when it jumps back, you have a leftover damage, leftover waves in the panel, which are sometimes difficult to identify. And that's what we call associated deflection zone. So at this next point is to mark up the damage. Okay. So we mark up the damage. Why do we mark up the damage? Multiple reasons. Number 1, it's better for the picture taking process. Number 2, it's, let me just write that down. So why do we mark up the damage? For picture taking. Okay. Number 2 is to explain it to the customer. Okay. Number 3, definitely when the service advisor or the estimator makes the estimate, This way you can communicate to your technician. Because the estimator doesn't always see the full extent of the damage. Maybe you see a part of the damage, you give a certain amount of hours for the repair, you give it back to the technician, and then there's additional damage where a service advisor didn't see. And that's why it's important to mark up the damage, okay? And the next reason also, it gives you, it helps you in the repair planning on how to fix the panel, okay? 1 second. So the way we mark it up, impact area, we make a crease, we make a little bit of a center part there. Let me just redo the video here and you see a little bit better. So here's the line, the body line, we mark first. The plastic deformation in the center, that's important for the repair process to be able to see where you have to grind off the paint properly. That's the elastic deformation. And then the crown is what often gets forgotten, is the crown on the outside, which needs to be marked up, okay? So let's look at this example here. Here we have the damage. Okay, the impact point is here. Okay, you also have the same picture on your PDF. If you want to go on your PDF to page number 10, you have the exact same diagram if you want to take notes there or take a poll. So here, for example,
you had the arrow on the you had the arrow on the door, Ralph?
Yes, now I do.
Perfect. Larissa,
there's my arrow.
Possible just to run the poll on this?
Okay, this point here, what's this pointing at on the damage? Okay, this one here, for the ones who want to take a poll, is this elastic, plastic, or crown? What do you think? You can answer the poll, which is in the middle. Can we go on, Dave?
Yeah, we just give it 20 seconds to answer the question. And then we take the poll down, see what everyone thought, and then we move on. Maybe wrap the poll up there, Larissa, if that's okay. We have a result. Elastic, Ralph. Followed by plastic, followed by crown. Okay.
So let's see what we find out. 1 second. So here, what happened here? The impact happened here. So this is my plastic deformation here. The metal is stretched. We have a body line. Okay. The next thing we have here are elastic deformation is down here. So all of this got pushed in from the impact. Okay. And the next thing what happened as this damage was pushed in, the crowns here got pushed out. So these here are crowns, and the way we mark them is like eyebrows. Okay. So this falls in the crown section. Okay. And now not to forget, and that's why we show, and it's important to have a proper lighting. You have also here crowns back down here, because this is actually easy to fix up here. The challenging now comes down here. So here we have a double metal from the flange around it, where it's pushed out from behind. So we have a crown here. And even more importantly, down here on the bottom, here, see this here on the light. That's why it's important to have good light on the damage there. Okay, this here is a crown. Okay, and this is actually a difficult part to repair, and this is what actually takes the whole time. Okay, so here you see impact area, quite easy to fix. Crowns, easy to fix, but actually on this whole job, the difficult one is the crown down here. That's the reason to identify the damage the right way. Okay, now let's look at another one over here. This is the trunk, which we'll be repairing in a second. Okay, 1 second here. So what do we have here? Trunk. Okay. So the impact went this way. Plastic deformation, elastic deformation, and here is the crown at the top. Okay, crown here, crown here. You see a little bit back here, there's another dent back here. Okay. And then also not to forget, we have a crown over here. Okay. And these are the type of damages you tend to miss if you don't have a proper light and you don't have a proper damage analysis. Okay. So let's move on. We've identified the damage, we've marked up the damage. Okay. So let's do 2 repairs, edge repair and rock body line. So edge repair, what happens? Impact area, impact comes from the left, pushes in. As the impact pushes in, you get the crown, pushes out at the top and in the bottom in this example. Okay, again, push in, and then the energy pushes the crowns on both sides out. Okay, so here we have red area for the ones who want to take notes on the PDF. I know I'm going a little bit fast here, out of time reasons. I already feel I'm going to run out of time. So the red area is the impact area, the green is the elastic, and the crown is the yellow one. Again, here on the lower example here, on this damage here, just on the right side, if you see it like this, from where you think the impact came from, you can put it in the chat. G for green if it came from the left to the right, B for blue in a 45-degree angle, or Y for yellow, I guess, from the top to the bottom. Thank you. Who's that? Frank. Good job, Frank. Thank you for commenting on that from the top down. And that's important to identify because now it helps you of which way to pull the damage, where to address the crowns at. That's why it's important to identify the damage direction. Okay. So now what we do, we have to repair the damage. We pull it out. We pull it out, and then we have to address the crowns. Okay. So now we go over to our first damage that we fix. Okay. So here we have our damage. Rocker panel, something easy. Impact area is here. Elastic is all the way down here. And very important to see is the crown down here where the metal has gotten pushed up. Okay. So we have here rocker panel dogleg type of damage, a typical thing. And if you look at here, so the red is the impact, green is elastic, and the yellow is the crown. Okay. So what do we need to do? We need to pull out in the opposite direction and at the same time apply pressure on the crowns to help remove the dent. Okay, and that's important. You cannot just pull out that damage. So here we have the types of tools available that we can use to pull out the damage. On the left side, for example, is heavy damage. That's why you have the plus at the top. So if the damage is heavy, you first start with bits and bridges. Then puller, T-handle. If you have access from behind the levers is always a good an option to use. And then the glue system is also an option to use, which I can show at a later session. Okay, so I'm going to weld on the bits. Okay, so let me show you that. So the way we need to do, we mark out the area where we're going to weld. 1 second. So here you see, so actually the area where we weld is not on the round area, what a lot of technicians do wrong. I show you here. if you weld it here or if you weld it here, that makes a big difference. Okay, because if you weld it here on the radius part, then you will pull, you will get a hole on the edge. Okay, and that means you'll have to weld it back, weld the shot on the back side. Always weld down here on the tangent line. Okay, don't weld on the round area, weld on the tangent point. So back here to our damage, we're gonna weld just below the round area. Let me just okay. At the beginning, we space them out, and now here in the center part, we will go closer together, and we will do stagger welding. One down, one up, one down, one up. Okay, I'll show you here. So this way we get both the lower belly, I call it, and also the top line. Okay. It's key to put as many as possible. This way, you distribute the force that you require to pull out the damage. Okay. Let's say each bit, the pulling strength on one bit is plus or minus 50 to 80 kilos, which is around 100 to 160 pounds. Okay, and if you need more power, you can distribute the power through more bits. And the way they are long holed bits. Okay, meaning you see you have here a long hole, meaning when you're pulling out the damage, you will pull out the deepest first and pull out the panel straight out. All right, so you apply the bridge. And now the key thing with the bridge systems is not just to use a sliding hammer to wank out the damage. What you do is you apply a pulling element. Okay, and now you see this crown here is holding in the damage. So what I do, I just apply a little bit of pressure here so the tension builds up. And now this crown here is holding in this damage. So the key point is now with the hammers, you go in and you do the tension relief. So here's the tension on the bridge, quite stiff. And now I go in. See now when you go back, you see the bridge is loose again because the tension relief in the crown has taken away the pressure. So now I apply the tension again. See now it's stiff again. Now I go back and I do the tension relief on the crown again. The reason we use two hammers is they're aluminum. You should not hit hammer and hammer. When you use two hammers, you can vibrate less, so you can be more precise on the hitting what you do. Okay. Okay, so the body line is coming out. And now here we can pull out the lower damage here. Remember, a good metal finish starts at the beginning and not at the end. Then you can check the body line. You can also check it with the laser, if the line is straight or not. And if it's all good, then you can take it off. And just take off the bits. after we take the inner puller. So then we still have a low area. So this is the inner puller device here. Low area. Now you can go in. You can pull up the low areas, okay? Then you check the elevation, crisscross.
Hey, Ralph, this is Patrice here. We have a question here in the chat that someone is asking if we can reuse the bits.
Yes, 10 years.
Okay.
If you want, there is a bit sharpener. Okay, and you can shave them at the top. Okay.
Okay.
So, what I wanted to show here quickly, just the different types of ways you can apply the bits. The top left on this example is a stagger welding, which I just did. The next step on the door panel would be the inside edge pull. The right side would be for surface areas that you apply, and then the area pulls are on the bottom. Okay, so here you see stagger welding at the top, at the bottom, up and down. In the center, you weld them close together. You pull in the center, and always important, tension, tension relief, pull, tension relief, so it's always a mix-up, okay? It makes a big change on what you can repair, how fast you can repair, and how clean it is, okay? Again, here's the tool selection, the finishing, then you go off into the inner puller, sliding hammer, and T-handles for the finishing, and that's the next step, all right? So the next thing will be the trunk, okay? 1 second. So the trunk, what happened there? It's not exactly the same panel, but the impact got put in, and you always look for the crowns. Okay, that's the key point, is to establish what happened, where did the metal go? Okay, that energy has to distribute someplace. Okay, so to repair that, then we pull it out and apply the bridge and apply pressure on the outside. Okay. Let me just jump forward. Here we have our trunk, which I identified before. Okay, this is the damage. All right, here we have the damage. Okay, now we're going to take away the paint, and what traditionally what people did, they took away too much paint. We're going to reduce that to keep it to a minimal size. So here we go. Second. So here we have the damage. Just take off the light, and it's better to get a visual here. Again, don't weld on the round area. I'm going to weld one on the round, below on the tension point, and one below in this area to get out this belly. The second stage, I have to remove the paint here to pull out this lower area here. So the spark was because I did not properly clean the E-coating. So now I'm going to go down because this here is the lower area. One down, one up, one down, one up. And don't be lazy on putting on bits. A lot of people do the mistake. They don't put many on there. And what's going to get? You're going to get waves in there. And you're going to have to spend more time on putty shaping. Okay. If you want to reduce the amount of putty to apply and how many coats of putty to apply. Each coat of putty takes us plus or minus 20 to 30 minutes. And if I repair like this, if I put 3 coats on it, it takes an hour and a half just the putty trying. If I do a little bit more, spend more time on a higher quality metal finish, I reduce the amount of coats I apply. It's a higher quality. And at the end of the day, I'm faster and it's easier process for the painter. Okay. OEM recommendation on that side, I don't know if anybody knows, maximum we can apply 2 millimeters of putty to an outside panel. It's actually a lot, but the aim is just to reduce the amount of putty we put on. Okay, so here we go. On the outside, I can space it out a little bit. Now again, I put on my pulling bar. Open up the center. Here you see from the top down, I'm about 1 centimeter in from the damage. Okay, I don't know if you see it there, if you get a good visual on it. Okay, so again here, put on the bridge. So what we do, we apply a little bit tension on the bridge. Okay, and now tension here, and at the same time tension relief. Don't pull out, don't get too greedy here. Just pull out. And what's gonna happen is this tension is gonna build up here on the crown, okay? So you can start hitting it here. So I pull till you have the tension here, and now I hit the crowns. See, pressure is gone. Again, tension on. If you look up here, the centimeter body line which got pulled in. Okay, let me see if I can get ruler here. See, body line is out already. Quite easy to do, easy job. Okay, get the visual, get the light back on the game. Okay, the light is actually what you see the best before your hands. Okay, so we check here the crowns at the top. There we can apply with the rubber tips on the hammer. Then we stabilize the bottom area. Don't take away the bridge. A lot of people take the bridge away too early, but keep it in there. Keeps the body line in shape. Okay. Now I can just go in with the T-handle. I don't need a lot of power. Just need to get up here along the line, small pulls. Okay, see, the damage came out quite nicely. Take it off, check where we're at.
Just giving you a bit of a time check, Ralph, maybe about 5 minutes.
I thought Patrice said I can go a little bit longer. I'm just kidding. Oh mon Dieu, mon Dieu.
You're doing good, Ralph. You're doing very good, actually.
Oh mon Dieu.
Keep going.
Oui, merci, monsieur. Ici, après, encore ici, une petite bosse là. Oui, pour les finitures. Maintenant, avec le inopuller, encore une fois. For the French-speaking people, not that I speak French. So now you can go in, work out the rest of the metal, sanding block, get that going. Okay, spend more time, take off the paint on the lower area. And now an example, here we have a small dent. See this small dent here? You can use the T-hop box for that. Okay. So the waves on the outside we can use with the T-hop box. It's often a combination of the repair. Another way we could have repaired it by using the glue system here, by using these glue tabs on the body line. That would have been an option. I could have used here, for example, is the round area. We could have used the speed lines for that area to pull out the damage. Okay, that's another way of doing it. Or up here, the body line. Okay. I hope it was interesting. I was flying through the last part. I really apologize for that.
No, you're good, Ralph. Ralph, I have a question here that came through the Q&A. The question is that some OEMs request a cold repair. Does fastening the bits apply too much heat?
A cold repair on the outside skin. Well, none of the German manufacturers do that.
Well, obviously the glue repair you just showed probably answered that question.
Yeah, you can use the glue, something on aluminum. This can be used. Okay, it has its place, but you're never gonna get the same metal finish as if you're using the flat line or with the bits. It has its place. You can use it, and we can show it to you at a different class.
Mm-hmm.
Okay, they are quite strong, but opinions are split if it's better or not. I mean, in some places, yes, but not in other places. At the end of the day, if you have big damages like this, if you want to fix big damages, glue is an area, but I would, without welding on the bits, it's going to be tough to cover the heavy damages too, which actually is the main part which do improve your cycle time in the repair center.
Important thing here is also, Patrice, is just the burn through. So the reason, one of the reasons, apart from the waves, for putting so many bits on when you're doing a repair, is then actually the heat transfer in each bit application is almost zero. There's no burn through. There's no damage to the heat coat on the backside. So this is how to address that particular point.
So this was really fast. Normally we have a little bit more time for these for this content in an E-class, damage analysis. Before that, we can do observing damage analysis, and then repair process. And there would also look more precise in the cold repair method. And then next to that would be the aluminum repair process, how to repair aluminum panels, and then naturally also the plastic repair procedures on the bumpers. All right. So from my side here, thank you to everybody. I hope you got some value out of it. Yeah.
Thanks, Ralph.
Oh, nice absolutely. Job. Yeah. Thank you very much, Ralph. This is much appreciated. Very good job. And Dave, do you have any words here to close? And then I'll move on with my slides.
So one of the things which hopefully will add some value, a little bit more time to go through it, is I think you're going to share the access information to go on the to get onto the Learning Center and look at the e-modules. So we've put 3 e-modules up there. Damage analysis, which is what we were doing where we're marking up the panel, takes you through a learning module on that. Edge repair, which is what we were doing on the rocker panel. So that again takes the process. There's questions, there's interactive, so can develop the learning, go back and reinforce some of the ideas we've covered. And then also there's a body line repair in there, which is similar then to what we were doing on the trunk. So
Okay.
you're going to send out, just create an account, go in there, and if you have the time, each e-module is about 20, 25 minutes.
Okay.
And certainly for those of you that are listening or watching that are technical, I think you'll get some more value from those and just reinforce some of the themes.
And Dave, I saw a question around the equipment or the type of equipment. So maybe if you want to make this available or tell us what it is, we can probably post it where we post the documents and also the recording, so people can refer to it later on. Because I saw a couple of questions regarding what type of equipment is that, what brand or things like that.
Oh, okay. Yeah. Happy to do that. Thank you.
Okay. Very nice. So I'll just move to my slides here. Okay. So, well, I just wanted to thanks everyone. I mean, this was fantastic. I don't know how I was looking at the chat box, and there was a lot of very positive comments here, and this is great. I mean, there's nothing like a live thing, and that I think this comment came from Harold in Calgary, and thanks for the comment, Harold. And you're absolutely right. There's nothing like the real thing to see it live. And Ralph did a fantastic job, Dave. I mean, this is very good. This is recorded again, so this is going to be available at the very soon via the ccif.ca website. And I hope you enjoyed it. This was great. Really, I'm looking forward to see the recording again. And we're going to have a similar session coming up in March. Another technical session. We have another one, a management one coming on this afternoon. So, well, on behalf of the CCIF and on behalf of all the sponsors, Dave, I want to thank you very much for you and your team to make this available. I mean, I don't know. Sure everybody knows that actually from your training facility in Switzerland. Am I right?
So I'm sorry, say that again. It just broke up at the wrong moment.
Oh, I said I think the Ralph was at the live from Switzerland. He was at your training facility in Switzerland. Am I right?
He was actually, yes.
Yeah. So it's getting a little late for him. So we appreciate
the wonders of the modern world. We can all be together in one place.
Yeah, absolutely. So thank you very much. I appreciate that, Ralph. Fantastic job. Thank you. A lot of good comments here in the chat box. So.
It was a pleasure. Thank you for having us, Patrice.
We appreciate that. Yeah.
Enjoy the rest of your day, everybody.
Yeah, absolutely. So thank you, everybody. So we'll reconnect soon. And just to continue again to say thanks to our sponsors. That wouldn't be available without them. So I just want to run that one more here. So thanks everybody. Thanks to all the sponsors. Thanks everyone for the attendance. And just in a couple of days, there's a little bit of editing we need to do to the video, but in a couple of days, you will be able to go to the website and look at the recording again. And that was great, fantastic. So we'll make sure that we have the documents and all the information that you were asking through the chat regarding the equipment. We'll make that available for you guys. So thank you very much to all of you. Thank you for your time. Thanks for the question. Don't forget to register for the virtual event in February. And thank you. So I'll see you. We'll see you in March. Thanks, everyone. Thank you now.